Okay, today we're going to look at assignment number 4, compounds containing polyatomic ions. So as you recall, each element gives up a certain number of valence electrons, and we use those to create compounds. When we have a binary compound, that means we have two elements off the periodic table. The first one gets its full name, the second one you change the ending to IDE to represent it's an element off the periodic table. But sometimes we use groupings of elements and we call those polyatomic ions because within that ion, each of those elements are sharing their valence electrons to make that group, okay? That when you do that, polyatomic ions, you never change their name because that helps us to recognize how many atoms are working together. The other rule we have to remember is that it is a group. And to represent more than one group, we have to use parentheses before we put the subscript. So what I'm going to do is for iron, Roman numeral 3, which should be a quick review for our Roman numerals for the transition metals, I'm going to do each of those polyatomics in that first row. Then I expect you to complete the chart, write the correct name, whether it's a magnesium showing you a binary compound, or iron showing you how you write the name as a transition metal. And then the final step for this assignment is to state the rule for naming polyatomic compounds. So I'll start with my iron, Fe, and it's a 3+ because it's a Roman numeral 3. My other one is hydroxide, which is a 1-. This is a grouping of two elements working together. So we crisscross our numbers, 1 and a 3. I bring my symbols straight down. And in the box, I'm going to write Fe, just one of them, so just the symbol. But OH, I need to show that it's 3 groups representing 3 oxygens and 3 hydrogens, not 1 oxygen with 3 hydrogens. So I do the parenthesis, OH, then the 3. Okay, that distributive property that you use in math class. So let's do the same thing with iron here. It's a 3+. Now we have phosphate, which is phosphorus, oxygen, 4 oxygens hanging out, and it too is a 3-. Crisscross the 3's, bring the symbols straight down. Now, because they're each a 3, we do not need to. We're going to simplify and just write FePO4. Again, the 3's are the same, so we simplify to single numbers, okay? Let's do the last one in that row. We have Fe, 3+. We have a sulfate, which is sulfur with 4 oxygens. It's a 2- for that group. So we're going to crisscross the numbers, bring our symbols straight down. When I write it in the box, I have Fe with the little 2 subscript, but that SO4 has to have parentheses. Otherwise, you show 1 sulfur and 43 oxygens, okay? So by using parentheses, writing the SO4, then the 3 on the outside, I'm saying it takes 3 sulfurs and 12 oxygens to make that group, okay? Finish off this assignment and we will talk about the next one.